Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is question number 2, guys, from the mid-year examination, which was written in the year of 2024 in the province of Eastern Cape. And please do expect a total number of 9 videos, since the question paper has 9 questions in total. And guys, it's very important for you to know how to tackle exam questions. Yes, it will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do take this seriously, guys. It will give you an edge whenever you write your exams. Né? So please do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel as well by just subscribing. Okay. A block of mass 20 kg is at rest on a rough horizontal surface. The block is connected with a light inextensible string that is hanging over a frictionless pulley to another block of mass x kg. A force of 105 newtons is applied to the 20 kg block at an angle of 25 degrees to the horizontal to accelerate the entire system at 2 meters per second to the right as shown in the diagram below. Okay, so if the system accelerates to the right, it simply means this guy over here will accelerate upwards. Okay. The first thing that we must do, guys, is to choose a positive direction. If we choose our right hand side as positive, that means our acceleration will be positive as well. Okay, first question, they want us to define the term kinetic frictional force in words. Kinetic friction, guys, is just a non-conservative force that always opposes motion of a moving object with relative to the surface of an object. Kinetic friction is just a non-conservative force that always opposes the direction of motion that taken by the object relative to the surface. We must second question, we must draw a free body diagram of showing all the forces acting on the 20 kg block. Our free body diagram will simply be like this. Let me draw it over there. Man. This 20 kg is in the universe, so it will experience a gravitational force. That's weight. This thing also experiences kinetic friction. As well as the tension. There's a tension on the rope there. This thing is on top of a surface, so it will also experience a normal force, F normal, and then there's that applied force over there, which is at an angle, F applied. Excuse me about that. Let me file into silent. Okay, so that's how, guys, you're supposed to draw your free body diagram. Or if you want to, you can draw the one that has the components of the applied force. The one that has the components of the applied force, yes, you will have your weight, you will have your kinetic friction, you will have your tension, you will have your normal force, as well as the components of my weight. My weight will be divided into 2 components. Firstly, the vertical component, Fy, and the horizontal component, Fx. All together, whereby Fx is equal to the applied force and the cos of theta. Fy is the applied force and the sine of theta. Theta always represents the angle of elevation of our force relative to the horizontal surface. All together. So you could have drawn your free body diagram like this or like this. You would have found your full marks. Excuse me. And then now we are being told that the coefficient of kinetic friction between the block and the surface is 0.2. They want us to calculate the magnitude of kinetic friction. I know that my kinetic friction is equal to the coefficient multiplied by a normal force, né? But my system is accelerating to the right. This simply means that there is no vertical acceleration. So I can conclude that F net in the vertical dimension, F net in the vertical dimension is 0. And on my vertical dimension, I have three forces. I have normal force plus the vertical component minus the gravitational force is equal to 0. I can therefore conclude that my normal force will be equal to weight minus the vertical component. Are you together? The weight of an object is just mg, gravitational force, né? So for me to find the magnitude of kinetic friction, I'll simply say this is just 0.2, which is my coefficient. And then the normal force is just the difference between gravitational force and the vertical component. Gravitational force is just 20 multiplied by 9.8. The vertical component is just 105 multiplied by the sine of 25 degrees. Please punch this thing as it is. You'll find your correct answer. That's 0.2 multiplied by 20 times 9.8 minus 105 times the sine of 25 degrees. And this will simply give me 30.33 newtons. So the kinetic friction acting on the object is just 30.33 newtons to the left. We must always write the direction. Ne? Friction is always opposing motion and it's moving towards the left. Then now they want us to find the tension on the string. How can you do that? I know that F net is equal to MA. Are you together? The horizontal forces on the let me write over there so that I can see my free body diagram properly. They want me to find the magnitude of the tension. Né? How can I do so? I know that F net is equal to MA. I'm focusing on the horizontal forces over there since my body is accelerating horizontally. So F net is just the sum of all the forces. That's Fx plus the negative tension, and the negative kinetic friction is equal to MA. These forces are negative since they are opposing direction. So Fx is just 105 multiplied by the cos of 25 degrees minus tension, and frictional force we got it to be negative 30.33. This is just equal to 20 multiplied by the acceleration, which is 2. So therefore I'll see on the left hand side I'll have 105 multiplied by 25 degrees minus 30.33. Excuse me, this will be 64.83 minus t is equal to 40. Alright, together. Whenever I take the 40 to the other side, I'll end up having t being equal to 14.83 newtons. T will be 14.83 newtons. Okay, and then now they want us to find the mass X hanging on the block. The entire system is accelerating upwards, right? So the free body diagram, I'll simply have my tension and my gravitational force over there, né? So I'll simply say F net for this one is equal to MA. That's basically tension minus the gravitational force is equal to MA. So tension is basically 14.83 minus gravity is just mg, right? I'll simply say this would be the mass of the body is x, the gravitational force is just multiplied by 9.8. This is equal to x multiplied by 2, né? So 14.83 is basically equals to 11.8x. So divide both sides by 11.8. Why did I say 14? Guys, my math. 64 minus 40. That's 24. My tension was 24, guys. Please fix that, né? The tension is just 24. Ooh-wee. 24.83 newtons. 24.83 newtons, né? It's not 14, guys. I'm so sorry about that. That's 24.83. 24.83. So if I divide both sides by 11.8, so 24.83 divided by 11.8, this will simply give me a mass as 2.104 kilograms. So the actual mass, guys, of this object, the actual mass, which is equal to x, is just 2.104 kilos. That's how, guys, we're supposed to tackle the second question over there. So just stay tuned and wait for more videos. Thank you.